A few words on logic. Why saying an apple works. Let's suppose we agree to call a certain object apple. Then, every time we want to express that object in language, we naturally say the word apple. But what makes this agreement work? The answer is the principle of identity. In formal terms, if P, then P. That is, a thing is what it is. The very possibility of shared language depends on this basic logical idea. Without identity, our speech would be chaotic and reasoning would be impossible. From now on, we'll use the symbol to represent formal causation, not just temporal cause, but structural or logical dependency. This concept will be explained later in the text. This article introduces, in simple language, why identity is necessary for logic, why reasoning relies on formal logic, the idea of consistency and contradiction, axiomatic systems, and the problem of induction. 1. Identity and formal logic. Throughout history, many cultures developed traditions of argument and debate. For example, in ancient Russia, figures like Feofan Prokopovich practiced rhetorical reasoning. In ancient Greece, such people were called sophists, wise men skilled in the art of debate. The key point in such debates, the lack of fixed definitions. Without clear terms, any claim can be twisted or challenged. Take the word economy. One person may mean jobs, another household income, and another consumer spending. These aren't the same, and each view leads to different conclusions. Now, let's be fair. The world is complex. As Hegel argued, we cannot fully describe a phenomenon with just one static definition. But modern thinkers introduced a more pragmatic idea, effectiveness. For example, to explain why apples fall, we don't need Einstein's equations. Newton's gravity works just fine. The idea is, use the right model at the right scale. Still, we must preserve identity in concepts. Without that, logic breaks down. If terms aren't stable, conclusions mean nothing. 2. Two types of dialectic thinking. A medical example. Let's say Misha goes to the doctor with a fever of 101. 5° F. First doctor, confused logic. Misha, maybe you're sick, maybe not. You could take medicine or not. Who knows? Misha, wait, aren't you the doctor? Why do I have to decide everything? Second doctor, rational dialectic. Misha, your temperature shows a fever. That could mean an infection, but it's not flu season. Fever means your immune system is working. Let's run some tests to rule out more serious causes. Now ask yourself, which doctor would you trust? 3. What is formal reasoning? Formal logic begins with basic propositions like P equals it will rain today or not. P2 equals the sun will rise tomorrow. From this, we can build a more complex statement. Whether or not it rains today, the sun will rise tomorrow. This is logically true because P is always true by the law of the excluded middle. Either it rains or it doesn't. P2 is assumed true based on our everyday knowledge. So, the whole conditional is valid. P2 is a true statement. But if we don't know the truth of P or P2, we can't determine the truth of the full sentence. That's why we call it formal logic. It depends only on structure and truth values of the components. 4. Logical foundations. Most logical systems rely on 3 classical principles. Identity equals non-contradiction. A statement cannot be both true and false. Excluded middle. A statement is either true or false, not both. Note, not all logical systems require the second or third rule. But identity is always essential. Without stable concepts, there can be no logic. So, being logical means being internally consistent. If your reasoning breaks the rules of identity or contradiction, it's invalid. 5. Axioms and the induction problem. To explain phenomena, we often ask, can we build a complete system of axioms? To answer that, we must explore how we form concepts. A simple explanation, memory-based induction. Why do we believe the sun will rise tomorrow? Because it always has in the past, but that doesn't guarantee the future. One day, the sun will burn out. When that happens, the sun will rise tomorrow will be false. So inductive truth is not equal to logical truth. Still, in science, inductive truth is the best we can do. It's what lets us build models, test predictions, and correct ourselves over time. This is why Hegel's dialectical reasoning is still relevant. We constantly revise our frameworks based on new experience, from Aristotle to Newton to Einstein. Conclusion: induction is never perfect. It gives us working truths, but not final ones. Logic provides the structure. Science fills in the content. Always open to revision. Always grounded in observation.